All right, you guys, we're now starting on example 15, which pertains to more segment and angle proof, so get excited. And again, these do not have numbers on them, but it's okay. Remember, we're good with awkward and weird. We're going to make it work. I might run out of space because if you see, like, this one took a lot more space. I'm going to try to make it work because I would like to not waste paper, but we'll have to see. But anyway, so I'm given that M is the midpoint of AB and B is the midpoint of MD. And I want to prove that MD equals 2 times MB. So I'm going to go ahead and, well, before I mark my picture, I'm going to go ahead and talk about the given real quickly. So what do you always write first in your proof? The given. You guys said it. Nice job, nice job. So I'm going to write my whole given. So I'm given that M is the midpoint of segment AB. M is the midpoint of segment A to the B. And B is the midpoint of segment MD. All right, my reason, it was given to me. Nice. Looks like my pen's running out. Okay, we can do it though. Okay, so I'm given that M is the midpoint of AB and B is the midpoint of MD. So we kind of have some overlapping segments going on, and we also kind of have some overlapping, not really overlapping midpoints, but the midpoints will cause some of our segments to be congruent. So again, it's always good to see if any words in the given might be helpful to solve this proof. So do you guys spot anything in the given that could be helpful? Any words pop out at you that might be helpful to eventually show us that MD equals 2 times MB? Well, I spot the word midpoint. Do you guys see this? Midpoint. So go ahead and look in your notes and read to me, what is the definition of a midpoint? Holy hot dog, you guys. You guys are really good readers. You should think about narrating a story or something. But anyway, so if I know that something's a midpoint, what that means is it lies in the middle and creates 2 congruent segments. So let's see here. If M is the midpoint of AB, that means that these 2 segments are congruent. And if B is the midpoint of MD, sorry guys, that means that these 2 segments are congruent. Which if you see, we kind of have an overlapping segment right here, but it's going to be okay. Guys, so I have just defined the word midpoint. I have explained what the word midpoint means. So by my definition of a midpoint, I can say that these 2 segments are congruent as well as these 2. So that's going to be my next line. So let's see here. I'm going to say that AM is congruent to MB and MB is congruent to BD. Let's just say congruence. All right, and this is because of my definition of congruence. Sweet. I'm trying to write small because I'm trying to save space. Okay. So let's keep on going. So again, you guys, I'm trying to prove something that has an equal sign in it. Currently, the segments that I need something about MB. Currently, the only thing I have with MB is a congruent symbol. So guess what, you guys? I need to transform these congruent symbols into equal signs. So turn in your handy note sheet to what it means to be congruent. Look up definition of congruence. Well, if something is congruent, that means that their lengths have to be equal. So I can say that the length of AM equals the length of MB, and the length of MB equals the length of BD. I'm sorry, this should have a line over it. Jeez Louise, Miss Long. So I have defined what it means to be congruent. If things are congruent, their lengths or their measures have to be equal. And anytime you go from a congruent to an equal sign, like I've done here, or vice versa, an equal sign to congruent, That is your definition of congruence. So if you ever see those transform from one form to the other, we have just applied what it means to be congruent. So this is definition of congruence, which now I'm realizing I made a mistake. Good golly, Miss Sloan. I'm sorry, you guys. Today is not my day. This one is definitely definition of congruence. Let me erase this. This is not definition of congruence, Miss Long. Get it together. Okay, looking for my whiteout. I think I said the right thing, maybe. At one point, I said what it was, and then I just wrote the wrong thing, because I guess I was anticipating the next thing. So sometimes I do that. I'm thinking about the next answer, and then I say the next answer in the wrong step. But anyways, I'm rambling. I'm sorry, guys. The reason why AM was congruent to MB and MB was congruent to BD because of the word midpoint, which I underlined it and we defined it and we looked on our note sheet. So this is definition of a midpoint. Sorry, you guys. Jeez. Definition of a midpoint. Okay. So anyways, now that we've changed congruent to equal, this is called definition of congruent. So we define the word midpoint, which means two segments will be congruent, and then changing congruent to equal will be definition of congruence. Okay, so now we're on the same page. So sorry, you guys. The demon cats, they just get me left and right. I have to look out for them. Okay, so moving forward. Now, I'm trying to prove that MD equals 2 times MB. Now, everyone look in your nifty notes packet and tell me what is the midpoint theorem. What does that mean? Holy hot dog, you're correct. The midpoint theorem states that if you know the length of an entire segment and you have a midpoint, if you half the length of the segment, you get each individual piece, or vice versa. If you have a midpoint and you know one of the smaller segments, if you double a smaller segment, it will equal the length of the entire segment. Okay, so we're actually proving the midpoint theorem. We're proving that if I double a smaller segment, MB, I will get the length of MD. So since we're trying to prove the midpoint theorem, I cannot use that theorem in my proof. It's kind of like how you're not really supposed to use the word in its own definition. So this right here is the midpoint theorem. This right here. This is the midpoint theorem. Since that's what I'm proving, I cannot use it anywhere in my proof at all. Okay, so I have to show that without just saying the midpoint theorem, because you're probably like, oh, yes, I can just say that's true because of the midpoint theorem and be done with it. Well, guess what? It's not quite that straightforward, but it's going to be okay, you guys. So I need to introduce MD into my picture as well as MB, which I'm kind of starting to introduce MB, but I need 2 MB, so we have to get to that point. Okay, but I definitely need an MD. So which segments lie within segment MD? Which segments make up segment MD? That is correct. That is correct. They are segments MB and BD. So I know that MD will equal the lengths of MB and BD added together. So I'm going to say MD equals the lengths of MB plus BD. If I add these two together, they equal the length of the entire segment. So what is it called when we add up the smaller pieces of a segment together to get the larger pieces? Okay, we're adding segments together. So which one kind of sounds like adding segments, adding? Holy hot dog, it is the segment addition postulate, you guys. Yay, segment addition postulate. Okay, we're getting close, you guys. I think I might be able to fit this all in my paper. We'll have to see. I'm trying. Okay, so I'm really close, you guys. I want to show that MD equals 2 MBs. Currently, I only have 1 MB, and this BD is getting in the way, and it's irking me and making me bad. Okay, I need to have 2 MBs because that's what I'm trying to prove. I have 1 MB and then I have a BD. Do you guys see anything that I've written so far where I could change that BD into an MB? Because if I had 2 MBs, I'd be good to go. Do you guys see it? Let's look right here. is there any way from this piece right here that I can force that BD to be an MB whether or not it wants to be? We're going to be kind of mean. Yes, you guys, I can replace BD with an MB because they equal each other. So what is it called when you replace something with what it equals? You are correct. It is the substitution property. I better not hear any P-bombs being dropped. Okay, so I have MD equals MB plus I'm going to replace BD with MB because it's what it equals. So this would be MB as well. So since I have replaced BD with an MB, this is called the substitution property. Yay! Substitution property. Oh man, you guys, I think I'm going to fit it all on this paper. I'm really excited. Okay. So I'm so close, you guys. I have 2 MBs, and I'm trying to get the MD equals 2 times MB. Do you guys see a way that I could combine my MBs to get 2 MBs? Holy hot dog. I could add these 2 together. MB plus MB will give me 2 MB. So both of these together give me 2 MB. What is it called when we add together something on only one side of the equation? That would be to simplify. I'm simplifying. So yeah, you guys, did I end up with what we were trying to get in the end? Yes, I have. Double thumbs up. Nice, you guys, nice. Okay, that was wonderful. I know that the demon cats got me a little bit, but I saved myself, so it's okay. I redeemed myself, so I'm happy. I'm happy as a clam right now. I'm actually happy as a kitten, but being happy as a clam is almost as good as being happy as a kitten. So way to go, you guys. You just tackled your first 2 proofs without numbers in them, which is quite challenging, but we are getting through it, and I'm hoping that they're starting to make more sense the more that we do them. Nice job.